This gadget is the HDMI firewall. You probably know HDMI is a convenient way to connect to a monitor. Well, on top of audio and video transfer, HDMI offers plenty of other interfaces, allowing to read the resolution supported by the monitor, remote control, USB connectivity, and even an Ethernet network. Now imagine, you invite an external guest in your company and allow him to connect to a screen for his presentation. This is the perfect opportunity for him to hack your monitor and inject some malicious code, turning your smart TV into a backdoor to your company network. Even a standalone projector could in turn hack back the next computer connected to it to exfiltrate confidential information. There already have been some publications about such possible attacks, but knowing the quality of these ridiculously cheap smart TVs with complex interfaces and seeing how often they get updated, I'm sure they are 100% secure and free of bugs. For all others, you can just use the HDMI firewall. Just connect your monitor on one side and the device on the other. Now only audio and video data can be transferred, preventing the device from hacking the monitor, and vice versa. The HDMI firewall comes with a default profile for HD monitors, but this might not fit your equipment. Thus, when installing the HDMI firewall for the first time, toggle the edit switch 7 to on or allow. Plug the monitor and plug the device. The firewall will make a local copy of the monitor's edit information. Unplug the device and toggle the edit switch 7 back to block. Now the next device connected to it will see the monitor's actual supported resolutions, but all other functionalities accessible over the DDC interface will be blocked. This includes HDCP, and in case you still want to watch your Blu-rays which require HDCP, you need to unplug the DDC interface. For that, toggle the SDA and SCL switches to allow. Note that the whole DDC interface becomes unprotected, and even the edit information is directly retrieved from the monitor. Similarly, if you want to unblock remote control, allowing to switch on or off all connected equipment just using one remote, toggle the CEC switch to allow. And if you want to enable Ethernet networking and HDMI over USB, toggle the UTIL and HPD switches to allow. Now, the more interfaces you allow, the larger the attack surface becomes. But it's up to you to choose how much you trust your devices. This is why per default, only the 5V switch is allowed. This allows some monitor to detect when a device is connected. This is a ridiculously low attack surface, but increases compatibility. Now let's have a look at the evolution of the HDMI firewall. Version 0 was the first prototype. The HDMI firewall was actually presented at the IT security conference STIC. I just took the research done by the French IT security agency ANSSI and re-implemented it. This design is minimalistic, and having the connectors on both sides of the board allowed for easy routing of the high-speed signals. Version 1 comes as a dongle to be plugged directly in the back of the monitor, and a tab allows to permanently write protect the edit information. These versions were not easy to install because you needed to copy the edit information yourself onto the HDMI firewall memory using Linux commands. I even created a programmer taking care of this. It would read the edit from the monitor and write it back on the HDMI firewall. Version 2 embeds this programmer, making it a lot easier to install. It's now also an inline device, allowing to use it if you don't have direct access to the monitor's HDMI port. And finally, it also allows to re-enable individual interfaces which were previously completely blocked. And if you want to know more about it, just scan the QR code on the back and find plenty of details on the site. This is the schematic for the HDMI firewall, and it shows how it logically works. So here we have the two HDMI connectors, one for the monitor and one for the device. In the specification, they are called sink and source. And some lines are directly connected between the two connectors. These are the lines used for audio and video transfer. We don't need to filter them, they're directly connected. Now some other lines are not directly connected, mainly CEC and HEAC plus and minus. These go through this dip switch, and there you can actually select if you want them to be forwarded from one side to the other by enabling it, or if you want to block them by just completely physically disconnecting them. This way you can disable remote control, you can disable networking and USB connectivity or even ARC. Now the last interface are the SDA and SCA line. This is the I2C bus which is used for the DDC interface. And both sides, here this side on the sink side and here on the source side, are both connected to this microcontroller. So if on the edit switch you enabled it, the microcontroller will connect to the monitor and retrieve the edit information using the DDC interface and then store it locally. The next time someone is connected on the device side, then using the DDC interface From here, it can provide the edit information and just the edit information. Everything else which could happen over the DDC interface is completely blocked. Now, if you connect the SDA and SCLI, you re-enable the DDC interface, and in this case, the microcontroller just removes itself from the interface and doesn't interfere with it. Everything over the DDC interface is forwarded and not blocked at all. And this small connector here is just to program the microcontroller, because this is open source hardware. So you can file the schematics and board layouts of all the versions on the site, and even the firmware for this microcontroller, so you can change some settings or make your own custom HDMI firewall. Before I can test the HDMI firewall, I ensure only the 5V switch is allowed. Then I connect it to the programmer and flash the firmware. When I connect it to the device, the red error LED should light up. This shows that the firmware is running and currently no edit information is present. I allow the DDC interface and user monitor. If the desktop is displayed, audio, video, and DDC forwarding work fine. Next, I test the self-programming edit function by blocking DDC and allowing edit. When I replug the device, the error LED will be shortly on, indicating the information has been copied. The display should still work as before. Finally, I program a generic HD edit profile on the firewall and check if it is programmed correctly by reading it. Now the HDMI firewall passed the tests and is ready for you to be enjoyed.